Have you ever wondered why certain animals are found only in specific regions and not beyond? What if we tell you there's an invisible line that no animal, bird, or fish can cross? A bewildering concept, isn't it? A line so inconspicuous yet so powerful that it dictates the distribution of species on our planet. This line, my friends, is not a figment of imagination but a geographical reality known as the Wallace Line. Named after the 19th century British naturalist Alfred Russel Wallace, it's a boundary that separates the ecozones of Asia and Australasia. Remarkably, this invisible line running between Borneo and Sulawesi and Bali and Lombok has been a barrier for species migration for millions of years. Imagine, a line drawn on the water yet so influential that it controls the movement of the creatures of earth, sky, and sea. Intriguing, isn't it? Welcome to the world of the Wallace Line, an invisible barrier that has puzzled scientists for centuries. The Wallace Line, named after Alfred Russel Wallace, a British naturalist, is not a physical boundary but a zoogeographical boundary. This invisible line running between the islands of Borneo and Sulawesi in Indonesia and Bali and Lombok is more than just a geographical demarcation. It's a line that depicts a significant shift in wildlife. Now you might be wondering, what led Wallace to discover this line? The answer lies in his travels during the 19th century. As an explorer and naturalist, Wallace embarked on an 8-year expedition across the Malay archipelago, observing and documenting the diverse species he encountered. What struck him was a peculiar pattern. The wildlife on the islands to the west of the line was largely similar to that of Asia, while the fauna on the islands to the east resembled that of Australasia. This observation was quite baffling considering the close proximity of these islands. For instance, Bali and Lombok, despite being only about 25 miles apart, host completely different sets of wildlife. On one side, you'll find elephants and tigers, species typically associated with Asia. Cross over to the other side and you're in a land of kangaroos and possums, species you'd usually associate with Australasia. The Wallace Line, therefore, represents a sharp biological transition, a sudden change in the species composition that is not seen anywhere else in the world. And it's not just about land animals. This line also affects the distribution of marine life, with species of Asian and Australian origin sticking to their respective sides. So, what's the reason behind this stark division? It all boils down to geology and the ancient movements of continental plates. These movements have created deep ocean trenches along the Wallace Line that act as barriers, preventing species from crossing over and mixing. This discovery by Alfred Russel Wallace revolutionized our understanding of biogeography and evolution. It underscored the influence of geological barriers on the distribution and diversification of species, adding a new dimension to the study of nature. So, the Wallace Line essentially draws a line between two distinct sets of wildlife. It's an invisible boundary, but its impact on the natural world is profound and far-reaching. Interestingly, the Wallace Line holds significant implications for the study of evolution and the understanding of our planet's biodiversity. The invisible boundary, named after the 19th century naturalist Alfred Russel Wallace, is more than just a geographical demarcation. It's a fascinating testament to the power of evolution and geographical isolation. Let's consider this. On one side of the line, you'll find animals that are typically associated with Asian fauna, such as tigers, orangutans, and birds of paradise. Cross over to the other side, and the landscape shifts dramatically. Here, the creatures are distinctly Australasian, including kangaroos, echidnas, and cockatoos. This stark contrast in wildlife is a product of millions of years of evolution, sculpted by the unique environments on either side of the Wallace Line. The isolation provided by the deep oceanic trench along the Wallace Line has acted as a natural barrier, limiting the migration of species and leading to divergent evolutionary paths. This isolation has sparked the development of new species and subspecies, each adapted to their specific environment, providing a window into the forces of natural selection at work. But the Wallace Line doesn't just impact the distribution of species, it also offers important clues about the history of our planet. It suggests that the land masses of Asia and Australia were not always as close as they are today. Over time, tectonic shifts brought these land masses together, creating the unique biogeographical boundary we know as the Wallace Line. The Wallace Line also helps us understand why certain species are not found on both sides of the line. For instance, the Asian elephant, despite being a strong swimmer, is not found in Australia. Similarly, the kangaroo, a symbol of Australia, is absent from the Asian mainland. These patterns highlight the significant role of geographical barriers in shaping biodiversity. Indeed, the Wallace Line has reshaped our understanding of the natural world. It serves as a reminder that our planet is a dynamic, ever-changing entity, with each shift in the Earth's crust or change in climate potentially sparking a new chapter in the story of life. Despite the extensive research, the Wallace Line continues to baffle scientists even today. This invisible boundary, drawn in the depths of the ocean and the heights of the sky, has been the subject of numerous scientific investigations. Still, it remains an enigma, a mystery, a puzzle that we are yet to solve completely. The Wallace Line, named after the British naturalist Alfred Russel Wallace, has intrigued and baffled scientists for over a century. It's a line that seemingly defies the normal rules of nature, acting as an unbreachable barrier for many species. Theories abound as to why this line exists. Some suggest it's due to the deep ocean trenches along the line, making it impossible for certain species to cross. Others propose that it's a result of ancient land bridges that once existed, allowing species to migrate from one side to the other, but not back again. Yet, despite these theories, there remain many unanswered questions. Why can't certain species cross this line, even when there are no physical barriers preventing them? Is there something about the environment on either side of the line that is fundamentally different, making it impossible for these species to survive? And then there's the question of evolution. How has this line affected the evolution of species on either side? Have they evolved differently due to their isolation from each other? These are questions that scientists are still grappling with, questions that are central to our understanding of life on Earth. The Wallace Line, this invisible barrier in the heart of the Indonesian archipelago, is a testament to the complexity and wonder of our natural world. It's a mystery that continues to challenge us, to push the boundaries of our knowledge and understanding. As we delve deeper into the mysteries of the Wallace Line, we're not just uncovering the secrets of our planet's biodiversity, we're also learning more about ourselves, about our place in this vast and intricate web of life. As we continue to explore and understand the Wallace Line, we realize that our planet still holds many secrets waiting to be unraveled.
Please do like, share and subscribe to my channel.